Hey, hello, welcome. I remain Prosper Nwangu, and in this week's lesson, we're looking at hydrocarbons. Remember, for the past 4 weeks, we've been looking at carbon. We started first with describing carbon, its physical and chemical properties. We went next to talk about isotopes of carbon, the crystalline isotopes and the amorphous forms of carbon, the graphite and the diamond, the coal, the charcoal, and the rest of it. Then we dived into talking about the compounds of carbon, the oxides of carbon, the carbon monoxide, carbon dioxide. Next, we looked at carbonic acid, the hydrogen carbonate, and the carbonate. For this week's lesson, we're looking at hydrocarbon. This is an aspect of organic chemistry. I want to say that it is the basis on which you understand organic chemistry. Several times, a lot of students come to me and say, "Sir, we don't understand organic chemistry. We don't understand how to name organic compound," and the rest of them. They say this is the most difficult aspect of chemistry that I do not understand. I tend to tell them that it is quite simple. Just that most times these things are done in a haste, and we don't settle down to understand it. So the introduction to this lesson to organic chemistry, hydrocarbons, let's say hydrocarbons and an introduction to it, will help you better understand this lesson proper and help you. Most questions in WAEC about, let's go about 30% of questions you find in WAEC, depending on the year, 30 to 40% questions in WAEC are organic chemistry questions. So let's dive into the topic proper. What are our objectives for the lesson? The first thing you should learn at the end of the lesson is you should be able to classify hydrocarbon. That's the first thing you should learn. You should know how to classify hydrocarbon at the end of the lesson. It's not so important, but it will allow you to understand it even as we advance further. You can simply place certain families of organic compound, which we'll be naming as we advance forward. You can simply place them into group and allow you better understand it. The next one you're looking at is you should be able to state reason why carbon form a lot of compound. For the past 4 weeks, we've been looking at carbon, and for the next 4 weeks also we'll be looking at hydrocarbons, and this is all about carbon. Why do carbon form a lot of compound? We're going to be seeing why this happens as we advance. And lastly, you should be able to explain the term hybridization. It sounds strange, but it is really simple. What is hybridization? You find such questions in WAEC number 1 or between number 1 to number 5 question. You find questions relating to hybridization, and you may find definition. You may be asked to define hybridization in the theory aspect. So do well to know this. Let's dive in proper. So what are hydrocarbons? The first thing you should know, what are hydrocarbons? We're talking about hydrocarbons. Now, as the word implies, hydrocarbon. Some of you know the word hydro as meaning water, but not in this case. In this case, we want to look at hydro as derived from hydrogen. So the word hydrocarbon means hydrogen and carbon. So hydrocarbons are simply organic compound composed of only 2 elements, carbon and oxygen. Unfortunately for you, this is a wire question. You'll be asked to define hydrocarbon. You can't miss out 2 marks on this simple question. The question itself tells you the answer to the question. All right, moving on to the next aspect. How do we classify hydrocarbons then? How then do we classify hydrocarbons? There are a lot of classification of hydrocarbons we have out there on the internet and in various textbooks. You tend to find it difficult to classify hydrocarbons. So we don't have questions on classification of hydrocarbon in most of the exams you're going to be seeing. But the classification allows you better understand it as we move forward. Now, as we move forward, they tend to want to scatter up and confusion want to set in, but the classification tends to keep you in order, knowing fully well that this is this and this is this. We're going to see other forms of classification. When you advance further, you tend to see a reason why we have a different types of classification. I'm going to be using a standard, the New School Chemistry standard, to classify hydrocarbons. I'm going to keep it simple so that you understand it. So, classification of hydrocarbons. The first class of hydrocarbons we have is the aliphatic hydrocarbon, the first arm. And under the aliphatic hydrocarbon, we have the acyclic and we have the cyclic. So this is the first arm of classification of hydrocarbon. Let us look at the second arm of it. Under the second arm, we have aromatic hydrocarbon. And the major example, when we talk about aromatic at this level, the moment you hear the word aromatic hydrocarbon, we're talking about benzene. Benzene is the major example in regards to aromatic hydrocarbon. So what I want you to put in mind is the difference between the cyclic and the aromatic hydrocarbon. As we advance further, we're going to be looking at this. I'm going to refer to this diagram so that you better understand the difference between aromatic and cyclic. Then, of course, it is easier to understand cyclic and acyclic. We'll discuss it as we advance, and then aliphatic. Okay, that will not be a problem. That will not be a problem at all. Moving on. Tetravalency of carbon. What do you understand by the term tetravalency? Of course, the word tetra means 4, and the word valency talks about the combining power of an element. So now let's join them together. Tetravalency. Does that mean that carbon has a combining power of 4? Well, that could be the case. Let's understand this better by looking at the atomic structure of carbon. Now, the valence electron, in the valence shell, there are 4 valence electrons. It means the outermost shell, there are 4 electrons. So this means that carbon cannot undergo ionic type of bonding, because ionic bonding involves the transfer. Hope you can still remember that it involves transfer of electron from one atom. Since there are 4, for carbon to attain the nearest noble gas configuration, it means it would need to share electron with other atoms, and so it is called tetravalency. So this is important because most compounds, in organic chemistry or hydrocarbons, you would notice that carbon can only have a maximum of 4 bonds. It can't go below 4. It must be 4. It can be less than 4. That is one aspect. I told a student once upon a time, and he was amazed, and he changed his whole perception about organic chemistry forever, and he's amazing right now. So you should know that carbon can take a maximum of 4 and nothing less than 4 bonds, except in the case of carbon dioxide. That's a major case which you've been taught in the past, and several other cases, but we're focusing on the lesson. So you have carbon as 4 bonds. You'll be seeing organic compound, and then you tend to wonder, how many hydrogen do I add to this carbon? Well, the key is carbon can take a maximum of 4. If it's not up to 4, you add hydrogens, and if it is more than 4, you have to remove hydrogens to make sure that each carbon atom has 4 bonds, just 4 bonds. So that is just tetravalency of carbon. Moving on. Why then does carbon form a lot of compound? We've talked about in the past. We've talked about carbon for 4 weeks, and we're going to be talking about carbon for the next 4 weeks, and it could even extend to, you could study that as a course in the university and still not be done with studying carbon and its compound, organic chemistry in general. The word organic chemistry, or the subject organic chemistry, is based on carbon. Carbon is the center of it all. So we're looking at, why does carbon form many compounds? Let's look at that. Why does it form many compounds? The first one is its ability to catenate. Now, what does the word catenation mean? This means the ability of carbon to join with other carbon atoms, several carbon atoms. It could be as much as 2,000 carbon atoms in ring form, in straight form, in branch form. So this is catenation generally, what catenation means. So if carbon can combine with itself and form a really, really long chain, it means that it could form thousands of compounds. So that is the first reason why carbon forms a lot of compounds. The second reason why it forms a lot of compound is the ease with which it bonds to other elements. Now, if carbon finds it hard to bond with other elements, it means that it would not form a lot of compounds, different types of compounds. It will be limited to certain kind of compound. But because because of its ease with which it bonds with other elements, it gives it more options. Next, its ability to form single, double, and triple covalent bond. Not all compounds can form double, triple, and single covalent bond. You have nitrogen with 3 bonds, but it does not catenate. It does not easily bond with other elements. But carbon can form single bonds with itself, with other carbon atoms. It could form double bond, and it could form triple bond. Now, this is more variety for carbon, so it gives it a lot of options to form many compounds. Moving on, the last aspect which we'll discuss for the lesson is the stability of the carbon single, double, and triple bond. In other words, it's not limited in the sense that it does form single bond, double bond, and triple covalent bond, but also these bonds are stable enough to remain as a compound and not convert to other forms. So these are the reason why we have a lot of carbon compounds. So moving on. Characteristic feature of organic compound. Although we're talking about hydrocarbons, but hydrocarbon is under organic compound. It's an organic compound. It's a carbon compound. So we want to look at characteristic feature of organic compound. When we talk about organic compound, what are the general features of this organic compound? Let us look at the first aspect of this. Organic compound are generally covalent. Yes, they are generally covalent, and so will not dissolve in water. Water is a polar solvent. It will not dissolve in water, but will dissolve in other organic solvents, which are referred to as non-polar, and such as ether, alcohol, benzene. They will dissolve in these substances. So this is a general feature of organic compound. Let's take for instance your let's go with carbohydrates like the fluoroatom. It will not dissolve in water readily. Now we can have other compounds, other organic compounds. If you check out most organic compounds in your home, such as your fat, also will not dissolve in water, and that is what I mean by not dissolving in water and dissolve in other solvents. So the second aspect we're looking at is they have a tendency to form long, open and closed chain compound. This is talking about catenation. We've seen that in the previous slide. Moving on to the third, they are volatile, inflammable, possesses low boiling point and melting point. Check out most organic compounds you have. The moment you heat them, they just combust, they engulf in fire. They possess low boiling points. Talk about your petrol, your kerosene, most of them, not all, they possess low boiling point and melting point also. The melting point for the solid, they easily melt. The moment you heat, in fact, even sugar just easily melts when you heat it. So we have the fourth aspect. Some organic compound exhibit the phenomenon of polymerization. Now we advance further, we're going to look at what polymerization is. I'm not going to define it right here, and so that we don't waste a lot of time on this video. As we advance further, we'll see what the term polymerization means. But let me give you a tip. Have you heard of the term polyethene? Polyethene. Now ethene is a hydrocarbon. Now polymerization means the joining together of monomers of ethene. So when this carbon or these hydrocarbons join together, or this organic compound join together to form a long chain comprising of monomers, they are referred to as polymer. So that is polymerization generally. So organic compound has a tendency of forming polymers, unlike inorganic compounds. So the fifth one, they are non-conductors of electricity. Organic compounds are generally non-conductors of electricity. Moving on. So what is hybridization? What do you understand by the term hybridization? In this case, you need to settle down. Wow, you're going to be learning a lot of things in regards to chemistry right now. I wish I could refer you back to your previous lessons in regards to principal quantum number. Well, since I can't effectively do that using this video, I'm just going to use this diagram to explain what hybridization is. Now let us focus on this aspect. Now what you have here is just the electron configuration of carbon. Carbon has an electron configuration 2 4, right? 2 4. It has an atomic number of 6, so we have 2 4. Now if you're talking about the Albert principle of representation, we have 1s2, 2s2, 2p2. So this is just the electron configuration of carbon. So it is the ground state. The ground state just simply means the normal state. If you write the electron configuration, this is what you have. So this is represented using the Hund's rule, and this is the representation. So now, what is hybridization? First, let's look at the definition we have there. Now, we are told that this is the joining together of two or more orbitals of the same principal quantum number to form new set of orbitals that are degenerate or equivalent. I'm not going to spend a lot of time explaining what hybridization is, because it does not really, you don't need that deep knowledge on it to answer questions or understand what we're going to be doing as we move further. But this is what it means. It simply means, now the word excited, just imagine you're excited. When you're excited, you tend to jump from one place to another. Now you only jump from one, you jump probably to the house of your friends or neighbor, those that you think are of the same energy level with you. Don't just jump from here and then go to a place where you don't understand or you're not conversant with. So now look at this. We have 1s. 1s is not conversant with the energy level 2. So there will be no jumping or excitement from 1 to 2. They are not of the same level. So now since 2 has an empty space over here, from 2s there's an excitement of 1 electron to 2p. So that is excitation. Excitation. That's the first aspect. We're told that the joining together of 2 or more orbitals of the same particular quantum number to form a new set of orbitals that are degenerate. Degenerate means of the same energy level. So now by doing so, these three energy level become degenerate. Almost becomes equivalent. Now that is sp3 hybridization. We're going to look at that when we come to the homologous series. We're going to discuss each hybridization proper, and I'm going to refer you to this lesson. So questions. What questions do you find in WAEC? You have questions referring to the ground state of carbon and also talking about the excited state of carbon. So you will need to know this ground state, which is the normal state, and also the excited state, these states. So the sp2 is simply after the excitement, 1s orbital and 2p orbital join together. In the first case, 1s orbital and 3p, that's why it is called sp3. So 1s orbital and 3p tend to join, the joining together of 2 or more orbitals. So 3 of them. So 1 sp3. That means 1 of s and 3 of p. In this case, we have 1 of s and 2 of p, so it is called sp2 hybridization. And lastly, sp hybridization, 1 of s and 2 and 1 of p. And that is what hybridization is, as simple as that. Firstly, let me summarize, talking about excitement of an electron from the 2s orbital to the 2pz orbital. Then we're talking about the joining together to form new set of orbitals that are degenerate hybrids. So for the sp3, 1s and 3p orbital and 3 of 2p orbital join together. For the sp2, 1 of s, that is the principal quantum number 2, 1 of s and then 2 of p, and lastly 1 of s and 1 of p. And so that is what hybridization is. So thank you very much. You've been wonderful so far. Now remember, your classwork is in the Google Classroom. Endeavor to do those classworks, and also remember that these things are graded. If you have any question, do not hesitate to chat me up in the Google Classroom, and I'm going to attend to your question. And if you've seen this video, please do well to write down questions, things you don't understand in regard to what you've learned, so that in the Zoom class we're going to discuss questions. I'm only going to entertain questions in the Google in the Zoom class, so that we can better utilize that 30 minutes of time. I'm not going to go through the whole presentation again. This is what the video is for. So do have a nice day and stay safe.